set of compounds. One last set of compounds we have to learn to name and write the formula for, and those are acids. Name. What's an acid? I mean, you studied them in biology class. They actually tell you what they were. Deoxyribonucleic acid. Well, what's an acid? What makes something an acid? Well, this is what makes something an acid. It's something that when you throw it into water and it dissolves, it gives off hydrogen ions. Remember, hydrogen ions are just a proton. That proton is tiny and charged. Because it's tiny and charged, it can get in and grab onto things and tear them off. Because it can get close, and it's got a charge, so it can hang on. So that's what makes acids dangerous, is that hydrogen ion has got a charge and it can attack other chemicals. Okay? So, what do you think all acids have to have in common? They have to have hydrogen in them. And actually, no, it's not just they have to have hydrogen. Hydrogen ion means it's acting like a metal, right? So they have to have hydrogen, and that hydrogen is going to be positive. We didn't say give off the hydride ion when dissolved in water. We said give off the hydrogen ion. Hydrogen ion implies positive, right? So you got to have a negative piece next to it. So writing the names of acids, the name has the word acid in it. I mean, DNA, deoxyribonucleic acid. Acid is part of the name. If acid is part of the name, it's telling us that you're going to have an H+. So the name is not going to talk about H+ other than saying acid. The rest of the name is going to be about the anion. What's the negative piece that hydrogen is next to? So different anions, ides, ites, and ates, have different ways of naming. We got the three endings. The three endings determine how you name the acid. Right, that's what the bell work was about, ide, ites, and ates. Okay? So, if the anion attached to hydrogen ends in ide, IDE, you take the prefix, you put the prefix hydro on, not hypo, hydro, and change the ide to ic acid. And you've heard these words before. The few acids you know the name of follows these rules. You put a prefix hydro in front and stick on ic acid. Because if I put H and Cl together, H and Cl, H is hydrogen, and that's going to make the hydrogen ion, and Cl is going to make the chloride ion. So I'm going to take and put the prefix hydro in front of chlor, and then change the ide to ic acid. So it's called hydrochloric acid. Hydrochloric acid, your stomach acid. The mistake people make, they think hydro means hydrogen. Hydro does not mean hydrogen. We've already mentioned hydrogen by writing acid. Okay. Hydro means no oxygen. Hydro tells me there's no oxygen. That's why, so hydro goes with "-ide," because the ones with "-ides" don't have oxygen in them. Hydroplane actually is a physical thing where you know how water resists you. Well, if you get up on the surface of the water, you're not touching the road anymore. So you're riding on water, so your brakes don't work very well in water. So you go sliding. That's hydroplaning. So hydro often means water, but in this case, it means no oxygen. That's what it means, no oxygen. So H2S. If I asked to name H2S, if you named it like an ionic compound, you would call it hydrogen sulfide. We're going to mention the hydrogen by writing the word acid. And we're going to take the "-ide and put "-ic acid and stick the hydro in. Now, for some reason, and I don't know why, maybe just because it sounds better, they put the UR back in. If you wrote hydrosulfic acid, I'd be okay. Okay? I'm going to write hydrosulfuric acid. I don't know why they put that. Maybe it just sounds better to them. But if you just put hydrosulfic acid, I'd be okay with that. So, got to do two changes if they end in "-ide. So if you're going to call this hydrogen sulfide, you have to change that to acid hydrosulf. That makes sense? If the anion has oxygen in it, so "-ide" means, hydro means no oxygen. If it has oxygen, it's not going to have hydro. But if it has oxygen, we're talking about the ones that end in "-ate" or "-ite. That's how we're going to know they have oxygen in them. Seem reasonable? So this is why we need those polyatomic ions today, because you're going to have to be able to pull them up and then change them into acids. Okay, so you change the ATE ending to "-ic acid, just like the other one, but you don't put the hydro in front. So you still use that "-ic acid. This time you don't have hydro, because hydro means no oxygen.
How do we determine that it's an acid?
It has hydrogen in the front.
So
Yeah.
if there's hydrogen in front, then we know
Well, yeah, because if the hydrogen's in front, it's acting like a metal, right? Because does that make sense? So if hydrogen's in front, it's acting like a metal, which means it makes hydrogen ions, so it's an acid. If hydrogen's at the end, the ones that we called hydride, those aren't going to be acids. See the difference? Yeah. So those names, they make a big difference. They're giving us clues. So if I put together, if I had HNO3, if I was going to name it like an ionic compound, I would call it hydrogen nitrate. But I don't want to call it hydrogen nitrate. I'm going to mention the hydrogen by saying acid, and the nitrate I'm going to turn to, take off the "-ate, stick on "-ic acid, nitric acid. So the way I remember this is, if I ate an acid, it would be icky. So "ate" and "ic" go together. I know "ic" goes with hydro and all that stuff too, but "ate" and "ic" go together. That makes that connection, I hope. The suffix "ite," I-T-E, we change to OUS acid, us. So if I had H and NO2, that would be hydrogen and nitrite. So I'm going to take off the "ite" and stick on OUS. So that would be nitrous acid. So nitrous acid. Okay. So let's try a few. HF. So here's the process I go through. Is the first letter H? Yes. So it's an acid. The other possibilities would be no, and then I'd add that first letter a metal. And if the answer is yes, then I would go to ionic compounds. If it's not H and it's not a metal, then it's got to be a nonmetal, and we're at the prefixes. So if that's what you look at. You look at the first element to decide which of the three rules to follow. Make sense? The first element tells us that. So HF, I know this is an acid because it starts with H. I know it doesn't have oxygen, so I can write, hydro. I can write hydro because it doesn't have oxygen. The anion would be fluoride, so I'm going to take the fluor. And instead of writing "ide," I'm going to write "ic acid." Ta-da! Hydrofluoric acid. So the H tells me to write acid. The lack of oxygen tells me to write hydro. H3P. Okay, H3P starts with H. I can say the second word is acid before I write anything else. That tells me about the H. The P is phosphide. Okay, and there's no oxygen, so I'm going to put hydro. And you'd write phos. And probably most of you are going to write phosphic. They put the syllable in phosphorus too. They put phosphoric in there. So I'm going to write phosphoric because that's the right name. But if you wrote phosphic, I would understand it. I don't know why they put it. It sounds better. Phosphoric acid sounds better than phosphoric acid, but. Okay. Pretty simple. H2SO4. Poetry reminds me of poetry. Little Johnny was a chemist, but Johnny is no more. So what he thought was H2O was H2SO4. What the heck is H2SO4? Well, it starts with H. It's an acid. It has oxygen in it, so I don't write hydro. SO4 is called sulfate. So, and if I ate an acid, it would be icky. So that'd be sulfic or sulfuric. S-U-L-F-U-R-I-C, sulfuric. Okay. And that's battery acid. That's why Johnny's no more. In your car battery, that's the acid in it. Okay. That's sulfuric acid, so this one should be pretty easy. Okay, it's acid. Doesn't get hydro because it's got an O. It's sulfite, so I'm going to write sulfurous acid. Okay, sulfurous acid. Make sense? Now, how to remember that us goes with ite? If it's us, I have to be there. Because if I'm not there, it's not us. It's you. Just remember, there is no I in team, but there is a me. This one's a little bit tricky. It starts all the way like this, acid, because it's got that H. H tells me acid. It's a polyatomic ion. The question is hydro or not. Does it have oxygen in it? No, it doesn't have oxygen, so we put hydro. And then cyanide, cyanic, hydrocyanic acid. H2CrO4. Second word, acid, because it starts with H. First word, does it get hydro? Nope. It's got oxygen. You either get oxygen or you get hydro. You can't have both. Now, CrO4 is called chromate. So this is chromate with the 8 taken off and the ick stuck on. Chromic acid. Really extra super tough compared to what we're doing before? Yeah, let's go the other way. You see the word acid? Write a capital H. If you're going to write the formulas, as soon as you see the word acid, you should write a capital H. Because it's going to be first. The name will tell you the anion. The rest of the name. If it's got hydro, it won't have oxygen. That kind of stuff. But remember, we're talking about ions still. So the charges have to cancel out, which means however negative your anion is, that's how many hydrogens you need. Everybody see why I wanted to know polyatomic ions before I started talking about acids? Why knowing them here makes this easier. Okay, so if it starts with hydro, it doesn't have oxygen, and you know the ending is going to be "ide." So my negative piece is going to be "ide" version of that anion, which means it's probably going to come off the periodic table unless it's things like cyanide. Okay. And so let's try a few. Okay, and I shouldn't have you too many instructions though. Try this one and then wave to me when you're done. There's a bunch of vowels there. Hydroiodic acid. No one's waving? No one's waving? Okay, but if you did this correctly, waving would be the correct thing to do. Okay, it says acid. I write H. Hydro, no O. Iotic, iodide. I. H is 1 plus, I is 1 minus. I. Should have waved. This is what vinegar is. Vinegar is a solution of acetic acid. I'll do the first half. H. Hey, so what's the anion for this one? Acetic must be, if it's ick, I ate it, right? So acetate, right? Acetate, one of our polyatomic ions, that was C2H3O2 with a negative charge. H was 1 plus. So the formula is HC2H3O2. Why don't they write H, why don't they just write C2H4O2? I mean, because you can't tell this is an acid by looking at it. What they're telling you by writing this way is this acid comes off, this acid stays together, or that hydrogen stays together. So they write it off separately to tell you this one's going to come off. Does that make sense? Okay. Carbonic acid. Well, starts with H. It says there's acid. Carbonic must be carbonate, which was CO3 2 minus. H is 1 plus. Doesn't add up to 0. H2CO3. However negative your anion is, that's how many hydrogens you're going to need. I mean, you could do the crisscross if you wanted to, but pretty lame crisscross. Phosphorus acid.
So is an acid more dangerous if it has more hydrogens?
No, it's actually what determines how dangerous it is how easily the hydrogen comes off. Some lose their hydrogen really easily, some hang on to it better. So in hydrochloric acid, every single molecule falls apart. In acetic acid, less than 1 in 10,000 falls apart. So that's the difference between strong acids and weak acids. Why we can eat acetic acid and we don't eat hydrochloric acid. Because it depends on how, some acid, the hydrogens come off easier than others. So acetic acid hangs on pretty well, so we can drink it safely. Battery acid, every piece falls apart, so you can't drink it safely. What? Citric acid, you usually eat a solution of that and it's okay. It's a weak acid, same as acetic acid. Actually, everything that you taste that tastes sour is an acid. If it candy has a sour taste, they made it acidic. Sour is your body's way of saying acidic. Because they put sweet in too, because we got different receptors. We got sour receptors, we got sweet receptors. So it's got sugar, but it also has some acid in there. So you'd be able to taste both those pieces. Actually, let's go back to carbonic acid, H2CO3. This falls apart to make CO2 and water, And those are the bubbles in your soda. So it's why flat soda tastes different than fresh soda. Flat soda loses sour because the acid makes the bubbles, using up all the acid. If you use up all the acid, you don't have sour anymore. You only have sweet. And the sourness, so that's why flat sodas taste different, is because they don't have sour, or they don't have as much sour. There's some other acids in there too, but the carbonic acid goes away, so they're less sour because they got rid of their acid. Okay. Hydrobromic acid? Well, acid tells me H. Hydro tells me no oxygen. Bromide. Br is a halogen, so it's 1 minus. H is 1 plus. Adds up to 0. HBr is the answer. Okay. So, in summary, those are the 3 types of formulas we got to be able to write. If I give you the formulas, decide which type first from the formula. Your first decision is which type. We've got 3 sets of rules. That homework tonight has it all mixed together in places. You got to figure out which set of rules to use. Okay? It starts with H, it's an acid. And from that point, I look at, does it have hydro or not? If it does have hydro, we know what to do. If it doesn't have hydro, is it ick or us? Because icky, I ate it. I am there if it's us, so it's ite. If it starts with a metal, it's ionic. And if it's ionic, remember to think about Roman numerals. The mistake made most often on the papers I graded last night was leaving off Roman numerals where you needed them. Because you only need them some of the time, and after doing a few where you don't need them, you forget you need them. So don't forget the Roman numerals there. I see that mistake all the time. A few people put them where you didn't need them, but that's not nearly as common. If it starts with a nonmetal, it's molecular, and that means you're going to have prefixes. You're just going to, so you're going to start with a name, and if that name has hydro, you know what to do. If it doesn't have hydro, it depends on if it ends in ic or us. If it's got Roman numerals in it, you know it's a ionic. If you see Roman numerals, you know it's ionic. But if it starts with a metal, it's ionic. And the other way, given the names, the second word is acid. It's an acid. Well, duh. And that means you're going to have H next to ate, or ide. And don't do all the hard work and then forget to put the subscript to make it equal 0. Because it's ions still. So just like ionic compounds, it's got to add up to 0. If the second word has a prefix, it's molecular. Just do what the prefixes say. If it's not neither of those two, it's going to be ionic. Or if the first word's a metal, it's ionic. And don't forget to do charges and make them cancel out when you're writing formulas. So given the names, you can figure out what type it is. That's your first decision. We've learned 3 sets of naming rules. The first decision is which of those 3 sets do I use? Sometimes they make it easy when they ask you questions like, name these acids. Name these ionic compounds. Right? But sometimes they just, here's some chemicals, name them. Is that right? Questions, comments, cares? Okay. That's what I